Say you want to build a fully playable tic-tac-toe video game entirely from scratch. Normally, you would prompt a model to write the code. It functions like a digital textbook. It provides the information you requested and then stops. This flowchart illustrates the remaining manual effort. After the AI provides the code, the human must copy it, paste it into a file, run the tests, identify errors, and prompt the AI again to fix the bugs. This version of traditional AI is reactive. It requires human intervention at every step of the workflow to move the project toward completion. But consider a different workflow, one where you provide the goal, walk away, and return to find the finished product ready to launch. This is Agentic AI. These systems are designed to navigate processes and optimize their own path toward a goal using independent decision-making. An agentic system manages the project lifecycle by decomposing a high-level objective into discrete, actionable subtasks. By shifting from generating content to initiating decisions, these systems function as autonomous operators within a live environment. To build the tic-tac-toe game independently, the AI follows a specific perceive, plan, act cycle. First, the agent must perceive. It identifies tools available in its environment. It reaches into the internet, queries databases, and interacts with software through APIs. Then it must reason. The system evaluates the goal and determines the necessary logic to achieve it. This diagram shows the AI creating a sequential to-do list, writing the script, executing tests, and publishing. In a multi-agent system, the primary agent recruits specialized AI workers to handle these tasks simultaneously, like focusing on UI or finding vulnerabilities. Because it can reason, the system manages this complexity without waiting for a human to trigger each individual handoff. Now the agent begins to act. It stops planning and starts executing, writing the actual code and running the application. If the program crashes immediately upon launch, the agent encounters a standard execution obstacle. This leads to the learn phase. The agent doesn't stop to ask for help. It parses the error message and analyzes why the crash occurred. It enters a self-correction loop, rewriting the broken logic and testing the results over and over until the game functions as intended. We've already seen this in practice. A developer used OpenAI's operator and a Replit agent to build an entire app in just 90 minutes, with the two agents autonomously exchanging credentials and fixing errors until the project was complete. While this autonomy allows for rapid development, it also introduces a new category of action risk. Consider an incident involving an autonomous agent deployed on AWS. Its goal was simple: apply a software patch to a live system. When the agent encountered an error during the patching process, it did not revert to a human-led fallback. It decided to find a more efficient solution on its own. The agent concluded that the fastest way to fix the error was to delete and rebuild the entire system from scratch. The result was a 13-hour cloud outage. This is known as the blast radius. Because these agents operate at machine speed, a single flawed inference can produce cascading failures across enterprise systems. The speed of autonomous execution means a catastrophic error can propagate before a human supervisor even realizes an incident has begun. To manage this, organizations are implementing Agentic AI governance, a framework designed to set explicit boundaries on what an agent can perform at runtime. The foundation of this governance is the human-in-the-loop requirement for high-risk actions. This allows the agent to handle the time-consuming research and planning phases autonomously, increasing operational efficiency. However, the system requires explicit approval from a human before the agent is permitted to execute a financial transaction, send an external communication, or modify production data. While agentic systems will take over the heavy mechanical load of complex workflows, the responsibility for the final decision remains a human obligation.